NASA's James Webb Space Telescope has captured worldwide attention, becoming the largest and most powerful space telescope ever built. So after making its White House debut last week, it's broken another record by discovering the oldest known galaxy in our universe.
Black holes as we know them are some of the most intriguing and complex objects in the cosmos. However, things got more complex, if not confusing, after NASA's James Webb Space Telescope sent back images suggesting that black holes do not exist at all. Will the absence of black holes change our understanding of the universe? If the objects seen are not black holes, what are they? Why will the absence of the black holes cause a paradigm shift in the space industry? Join me today in this video where we will explore this complex subject. Before we delve deep into the information from James Webb Telescope suggesting that black holes do not exist, it makes every sense if we answer this question in everybody's mind. What exactly are black holes? Here is the answer. Most people think of a black hole as a voracious whirlpool in space that is swallowing everything around it. In simple words, a black hole is an area of immense gravity in space that nothing, not even light, can escape from it. It is important to make it clear that black holes have got nothing to do with space at all. In fact, they are the exact opposite. Black holes have a lot of matter stuffed into the least possible space in the universe. As such, they are so compact, hence their strong gravity. For a better understanding, think of it like this. Our Earth, with a mass of 5.9 sextillion tons and a volume of 1 trillion cubic kilometers, is squeezed to fit the size of a peanut. It is just mind-boggling. As such, the tiny object formed is known as the black hole. By now, you perfectly understand why the black hole is not a hole or a ring as often misunderstood by most people. You will get a more perfect image of the black hole when you get to understand how it is formed. In most cases, a black hole is formed when a star explodes when it comes at the end of its life in a process that is generally known as supernova. It is obvious that in such an explosion, a lot of energy in the form of heat and light is released. As we know in basic physics, energy cannot be created or destroyed, but it can only be transferred or transformed from one state to another. Here is where the idea of the black hole is clearly illustrated. The energy and all the debris from the explosion of the star falls into an infinitely small point that is known as a singularity. This is the place where all the mass is trapped. After looking at the formation of the black hole, it will be easier to understand the form or physical structure of a black hole. There is no one better place to help you understand about the physical structure of black holes than 76-year-old theoretical physics professor Michio Kaku of the City College of New York. In a response to 14-year-old teen Michio Kaku breaks down the physical form of a black hole in a statement that reads, "For a non-rotating black hole, the most realistic description might be a black sphere. The sphere represents the event horizon, or the point of no return. Inside the sphere, there is presumably a tiny dot, the black hole itself. For a rotating black hole, the black hole itself is probably a ring of spinning neutrons, which does not collapse because of centrifugal forces. The ring is then enclosed by the event horizon." As earlier mentioned, the singularity has an intense gravity that enables it to suck everything around it. It is astonishing that it sucks even light. By the way, the name black holes is attributed to the object's ability to trap even light. Just like all other objects in space, black holes come in different sizes. A regular black hole, normally known as a stellar mass black hole, has a mass that is about 25 times that of the Sun. As you would expect, there are also huge black holes that are normally known as supermassive black holes, which have a mass that is millions or billions of times that of the Sun. Such black holes are normally found at the center of the galaxies, and scientists argue that the supermassive black holes are formed in the same period as their parent galaxies. They have also established that all the major galaxies have a supermassive black hole at its center. For example, in our galaxy, the Milky Way has a supermassive black hole at the center known as Sagittarius A, which has a mass that is 4 million times that of the Sun. Despite the huge mass of the black holes, they cannot be seen by a naked eye. Over the years, America's NASA has been at the forefront of studying black holes by sending spacecrafts and rovers into space for exploration purposes. The Voyager 1, Voyager 2, and the Hubble telescope are some of the most powerful instruments that NASA has sent into space. On Christmas Day 2021, NASA went a notch higher by sending a $10 billion telescope into space. So far, the Webb telescope has sent a lot of images from space that have captured even the attention of President Joe Biden. In a televised event, President Biden and NASA Administrator Bill Nelson shared the Webb's first images to the world.
America is defined by one single word: possibilities. Possibilities. I want to thank the team at NASA for once again showing that that's who we are. That's who we are as a nation of possibilities.
There is no doubt that the glorious images from the James Webb Telescope have clearly changed our understanding of the universe. For a long time, we have always known that Neptune is blue, but Webb Telescope established otherwise.
These are some of the sharpest images that we've seen of Neptune in more than 30 years.
Now, see, I looked at that and thought it was Saturn.
The entire space community is excited after the insane telescope revealed a new galaxy, which is the oldest galaxy that we have ever seen. But to be fair enough, the images from the James Webb Telescope were not just about good news in some cases. The images revealed information that has terrified the entire space industry. And one such scenario is where the images suggest that actually there are no black holes. The revelation has elicited many questions in the minds of astrophysicists and astronomers around the world. How possible is it that we could get it wrong after studying the black holes for such a long time? If at all black holes do not exist, is this a step progress, or are we moving backwards? Tough questions. Perhaps we can get the best answer not from an ancient astronomer, but from an American philosopher, Henry David Thoreau, through his famous quote that reads, "When any real progress is made, we unlearn and learn anew what we thought we knew before." If we are to be true to the quote, we must be ready to challenge some of the truths that we firmly hold. For many years, astrophysicists have always known that black holes are formed when stars collapse to form a single point that has intense gravity. If you can remember, earlier on in the video, we called this point a singularity. This far, it should be clear that the process of forming black holes is purely based on Einstein's theory of gravity. In Stephen Hawking's quest of understanding black holes, the legendary physicist used quantum mechanics in 1974 to prove that black holes emit radiation. Further research by Laura Mersini Houghton, a physics professor at UNC Chapel Hill in the College of Arts and Sciences, shows that by giving off its radiation, the black hole sheds. If the black hole continues losing mass and shrinks off, it will reach a point where it will no longer have a density to be called a black hole. Where does this lost mass go? Does it just disappear? If we say that it just disappears, we will be violating the law of quantum physics that clearly states that no information from the universe can ever disappear. And this is where the real issue is. Efforts by astrophysicists to combine the two theories leads to mathematical nonsense and leads to a problem known as the information paradox. Hence the research by Professor Laura, which is available at ArXiv, an online repository of physics papers that are not peer-reviewed and has accurate mathematical solutions to this problem.
From the outside, for all practical purposes, it does look like a black hole, but if by any means we were able to look inside, to peek inside this star, then we would not find a singularity at the center, nothing exotic at the center. And in that case, we don't end up with the information loss paradox.
Laura Mersini Houghton did this research together with Harold Pafer, who is a physics guru at the University of Toronto. The two physics experts have come up with mathematical calculations that prove that black holes do not exist. Professor Laura believes that her paper perfectly merges the two theories. In her own words, she says, "Physicists have been trying to merge these two theories, Einstein's theory of gravity and quantum mechanics, for decades, but this scenario brings these two theories together into harmony, and that's a big deal." In simple terms, Prof. Laura has proved that black holes do not exist. If you think Prof. Laura is alone, then you are wrong. There are way more other astrophysicists who are rejecting the idea of black holes. Although a pioneer of the modern conception of black holes, English astrophysicist Stephen Hawking changed his mind about the existence of black holes before his death. Before you criticize Hawking for shifting goalposts, remember that it is only a fool that does not change his mind. According to Hawking, it is true that there is something like a black hole, as seen in the images revealed by the James Webb Space Telescope. There is lots of evidence to support all this. However, black holes as we understand them do not really exist. Just like in 2004, Hawking can't actually prove this new concept of black holes one way or another. In his own words, he says, "A full explanation of the process," the physicist admits, "would require a theory that successfully merges gravity with the other fundamental forces of nature." But that is a goal that has eluded physicists for nearly a century. The correct treatment, Hawking says, remains a mystery. Other than Hawking, Steve Green also rejects the idea of black holes as we understand it. The theoretical physicist in Columbia University expressed his thoughts about black holes in a tweet that reads, "Black holes are where God divided by zero." Here, Steve Green echoes the words said by comedian Stephen Wright. To understand what the quotes of dividing by zero means, we will have to understand by some basic mathematics where dividing any number by zero gives you a result that is undefined or one that cannot be explained. If we put this into context, it is true that Steve Green and Stephen Hawking agree that the concept of a black hole is mysterious. The big question that astrophysicists like Stephen Hawking and Steve Green rejecting black holes have to answer is, if the objects seen are not black holes, then what are they? Quick answer: they are fuzzballs. Here is why. Under string theory, and as seen earlier in the video, black holes are neither black nor holes. On the contrary, they are neutron stars that resemble black holes. Space.com's Paul Sutter elaborates on this concept, saying, "Inside a neutron star, matter is compressed into its highest density state possible. In a neutron star, atomic camaraderie breaks down and dissolves, leaving behind just neutrons crammed together as tightly as possible. With fuzzballs, the fundamental strings stop working together and simply crowd together, becoming a large, ball of strings. A fuzzball. With the concept of black hole now challenged, there is a need to rethink how the universe came to be. If the black hole idea is in error, this simply means that the idea of the Big Bang is also non-existent. The Big Bang hypothesis postulates that all of space and time began as a single, extremely dense, hot point. In 100 billionth of a trillionth of a second, the Earth experienced a phenomenal growth spurt. The universe is thought to have expanded by a factor of at least 90 during this period of rapid growth, known as inflation, effectively doubling in size. During this period of rapid growth, known as inflation, the universe is thought to have expanded by a factor of at least 90. In the first 3 minutes after the Big Bang, the universe began to form the lightest chemical elements. As the universe cooled and expanded, protons and neutrons collided to form deuterium, a hydrogen isotope. Around 380,000 years after the Big Bang, matter cooled to the point where electrons could combine with nuclei to form neutral atoms. After free electrons were sucked up, the universe became transparent during the recombination phase. This light is still visible today as part of the cosmic microwave background radiation. The universe emerged from its dark ages approximately 400 million years after the Big Bang. This stage in the universe's development is called the reionization age. As gas clouds collapsed, stars and galaxies formed. Years later, more stars and galaxies formed. It is clear that the concept of the Big Bang greatly relies on the idea of a black hole. But with the James Webb Space Telescope in space, there is still hope that the giant observatory will unravel more mysteries. But wait a minute, how is James Webb able to study distant objects? The James Webb Space Telescope sensor systems and 4 cameras to monitor heat radiation in infrared light, a wavelength slightly beyond what we can perceive. Because our atmosphere limits infrared light from space, the Webb must function from orbit. To avoid interfering with the sensors, the telescope must also be extremely cold, at -364 degrees Fahrenheit. This is due to its location in deep, frigid space, which is helped by the protective solar shield. The telescope, powered by a solar array, might last for 20 years or more. Unlike Hubble in low orbit, which can be maintained, Webb's orbit beyond the Moon requires it to remain self-sufficient for the mission's duration. Webb has an impressive to-do list. Scientists plan to investigate the cosmos's origins, how galaxies originate and evolve through time, the life cycles of stars, and the mysteries of exoplanets. However, the most significant discoveries made by the telescope may not be in any of these regions. The most crucial part is that the Webb team is still in the early stages of the project, and the data acquired by the Space Observatory will be made public so that scientists around the world may begin a shared adventure of discovery. But does it really matter what happens billions of light years away? Yes, it does. Betelgeuse and the Sun are among the clusters of stars that make up our home galaxy, the Milky Way. Despite their differing sizes and hue, these stars are held together by the same physical laws. What if we woke up someday to a violent SME? Well, we are well adapted to our Sun's solar flares, and the Earth's magnetic field handles that oftentimes without even our notice. But will it be able to stand one episode of surface mass ejection? But even solar flares can be very dangerous at times. The billion tons of charged particles ejected from the Sun can get things messy on Earth. If unshielded from them, the solar flares can cause immense radiation poisoning to human and other living things. It takes 45,000 simultaneous X-rays to cause the death of a person, but solar flares can give you a dose of radiation equal to 300,000 simultaneous X-ray. This danger of radiation particularly threatens the astronauts on expeditions outside of the Earth's protective shield. Also, the geomagnetic storm can disrupt satellites' communication in orbit. The highly charged particles hitting the surface of the satellites can destroy it, rendering it dysfunctional. Furthermore, the high-flying planes will get bathed in this radiation. And on the ground, the geomagnetic storm causes a surge of current on the power grid, causing them to fail. Telecommunication systems will also be affected. And these things are not strange. They happened in real life on March 13, 1989, about 33 years ago. A powerful CME erupting directly towards the Earth caused a major power outage which lasted several hours in the northeast U.S. as well as Quebec and affected over 6 million people. Another one happened in 1859. But what will happen if the Sun experiences a CME or an SME, or even worse, still a supernova? It will be a disaster that can be equated to the apocalyptic Armageddon, and the NASA's observatory as well. The early warning systems will be the first to let you know what to expect, and that's all they can do. But here comes another interesting question. Could a black hole destroy Earth? The answer is a big no. Here is why. Remember that black holes do not go around in space-sucking planets, moons, and stars. Our Earth will not get into any black hole since there is no black hole near the solar system that can cause that. Even if a black hole with the same mass as the Sun were to occur around the Sun, the Earth will still not sucked. This is simply because this black hole will have the same gravity as the Sun. With that, the Earth and all other planets in our galaxy will just orbit that black hole just as they orbit the Sun. After all, there is no need to worry about the black holes destroying Earth since the JWST has proved that they do not exist, at least in the way that we understand them. What is your take on the existence or absence of black holes? Feel free to share your views in the comment section below. To this end, consider subscribing to our channel so that you do not miss out on the latest news.